speaking about our next speaker, Kailash. He's an educator and entrepreneur based in Bangalore. He founded AmpereWorks and a DIY hardware venture committed to innovative and no-nonsense engineering solution. His topic is From Concept to Creation, the journey of an open source watch proprietor at AmpereWorks. So whether you are a seasoned developer or a curious maker, the session provides a comprehensive view of what it takes to bring a complex DIY hardware project from concept to reality. So let's give a huge round of applause to Kailash for his talk.
Thank you. Sure. This is my talk's entitled From Concept to Creation. Basically, the journey of making a hardware product and trying to realize it, right? So I'll start with a bit about me. So I am was just introduced, I'm an educator from Bangalore. I teach at a high school. That was just me a year ago. This is what happens to you in academia in like a year, basically. They wear you down quite a bit. But besides, when I'm not teaching high school, I teach them basically electronics and 3D printing. So I've kind of weaseled my way into a high school without doing a BEd degree, basically. It was the few things that you can teach because there's no structured curriculum course yet for those kind of things. So I have been making things for a very long time. So a little bit about me, I spent most of my childhood in my dad used to work for a telephone manufacturer, Remington Rand, back when they made like landline telephones. And so I spent most of my childhood inside a telephone manufacturing plant. So just watching electronics manufactured, I was fascinated from a very young age. So I've made a lot of DIY amps, guitar pedals, all that through my 20s. Got interested in music. So last year I founded this company called AmpereWorks, primarily to get people making hardware here in India, which I find there's a kind of a divide between people DIYing their own hardware. It's kind of looked down upon here in a weird way that it doesn't really make sense, because it's not like we have a dearth of nerds. The nerd culture is really strong. But it turns out that if you make something with your hands, you are relegated to be a craftsperson and not really like serious about what. And not only that, you don't also feel that those kind of skills can be brought to bear on everyday life, right? So it's you wouldn't fix something in your own house. You just get an electrician to do that. Even though, I mean, it's quite simple for if you can understand software pipelines. I think the electrical system of a house is not very complicated. It's just a weird cognitive dissonance that people have. So I just wanted to solve that. A company in the template of like something like Adafruit, basically, so that sits between the hardware manufacturers and the DIYers, so that we can facilitate DIY. So yeah, to that end, I basically wanted to make a kit that would be the like a gateway into making and all of these things. So this was the T1. It's like a wearable that's using an e-paper display. You build it from a kit. It's network enabled. It has Wi-Fi, Bluetooth, all of that stuff. We intend to use it. You use it as a watch, but technically it's using Arduino code, so you could program it to be whatever you want. One of the suggestions that we've gotten is you should add a button to this and make it a set of dice, because if you are a D&D player, or like even if you play Monopoly or something, you know those games can go like hours, right? So instead of using an emissive display that consumes battery, you could use an e-paper display that would only that would help for these kind of like periodically updating applications. Yeah, so you could program it to be whatever you want. So that's the idea. So the broad challenges of making something like this. So there are three basic ones that I want to talk about today. So the double-edged sword of e-paper. E-paper is excellent. It's an amazing technology. Consumes almost zero power when not updating, but actually consumes a lot of power while updating. But that's actually, the technical issues are not the biggest challenge with e-paper. It's the economics of it, because Amazon is the 800-pound gorilla in the room. They have almost a monopoly on the e-paper technology in a way, because they brand it e-ink, which is the same broad technology, but you can't patent a whole technology. So they have a particular brand name that they use for the Kindle and all of this. The second is the choice of microcontrollers. There has been almost like a revolution in DIY microcontrollers over the past few years because from Arduinos to ESP32s to all these things, like basically there's a huge plethora of microcontrollers that you could use. In fact, it's a paradox of choice. Trying to nail down which microcontroller to use is actually the challenge now, actually. Timekeeping, yes, this is, turns out if you want to make a watch, it's actually kind of challenging to do timekeeping completely in software. You still need a hardware component. So these are the three things we're going to be talking about. Right, why e-paper? I think it's because it's geeky. It appeals to the inner bibliophile, right? So it's like looking at a page, which is, I think, half the selling point of something like the Kindle or something like that. It looks completely different from any other pixel-based display technology. So yeah, and it's also rare in the landscape of commercial wearables, except for Pebble, rest in peace, because again, I think it was because of the unit economics of e-paper that Pebble was not able to compete. Otherwise, it's a great idea, and it's a unique looking display for sure. Yeah, so minimal power draw for periodically updating content, right? So it doesn't draw any power once the screen is updated and refreshed to a particular display thing. It doesn't draw any power. The T1 especially was designed to be a DIY kit. It's so that you can integrate a product and see what it's like to make a basic wearable from scratch. What are the broad what are the broad components, all of these things, so that these things are not black boxes. It is not meant to compete with existing smartwatches, which are a race to the bottom of like how we can get sensors, how many sensors can we pack into it, right? Like, do you want to put a heart rate sensor, you want to put a EKG, EEG, whatever measurement you want to put into it. Samsung's doing continuous blood pressure monitoring, which is all cool, but this is not what this is. This is a complete different thing. It just shows the time. It can maybe show your little art or doodles if you want. You can program it to do those kind of things. Yeah, it's explicitly simple, and it's designed to actually decouple you from your phone a little bit. It's not doing notifications and all of that stuff. So what is e-paper anyway? So it stands for micro-encapsulated electrophoretic display, which is a mouthful. And if I just want you guys to, again, high school teacher, so I think I bring it back to a high school demonstration that you must have seen at some point. This is how it's electrophoresis, which is the idea that you put a charge between two plates and you move compounds based on their electric charge. They move a certain distance based on how the compound is inherently charged. So you get this physical movement of organic molecules in this case, but it could be an inorganic molecule. As long as it's a charged particle, you basically, it's like, it's like electrolysis or anything. It's the inverse battery, right? You put a charge on these two plates and you move particles because of their inherent charge. So this is the structure of your e-paper display, right? So there's a top plastic layer on top, and then there's a transparent electrode, which is there for most display technologies, including LCD. It's just a indium tin oxide layer on top. Then you have these microcapsules, which lead to the actual not pixel-looking part of this display, because if you've ever wondered why, and I think people who would work with fonts would know this, right? Why a thing looks different on print versus why it looks different on a display, because of the idea of there are no fixed pixels. There are cells, there are dots on a piece of paper that are allowed to bleed into each other. So that gives you the nice, smooth, inbuilt anti-aliasing of text on print as opposed to a display. So that gives e-paper its like unique structure. It has these micro capsules, which are basically filled with these white and black particles. And one of them is charged positive, and the black is charged negative, and the white is charged positive. And then basically you apply a high voltage charge on those two electrodes, the top and bottom. and that allows these particles to migrate. And how long you apply that charge will give, because there are actually physical particles moving, how long you apply that charge can determine the contrast of the display, like how much of the black moves and how much of the white moves and all of this. It's also, it also includes, basically you have to think of the order of operations when you are doing this. So if you want to change it from black to white, you'll have to send the black down and then send the white up. It's not a, you can't do it instantaneously because these things are physically moving objects. The chip that makes it all possible. This is the Seed Studio Zhao. It's a ESP32 microcontroller. It's kind of, it's got all the features you need to get up and running out of the box, basically, with minimal messing around. It doesn't require you to spin your own PCB because of how the features that they've integrated into it. It has inbuilt battery charging, which is kind of a rarity among microcontrollers for DIY. It is way overkill for this application, really, because what you would want to put in a watch or something like that, say a Philips Hue or some IoT connected thing that just has a few bits to deal with, right? Like time or just changing a light color or something like that. You'd put an ESP8266, which is a universal thing. It costs almost like $80 a pop in retail and much cheaper as a large manufacturer. But this was chosen because, again, ease of use. It has Wi-Fi, Bluetooth. So it has a high hackability factor. You can customize it to do various things. It could give you quotes, it could give you location-aware messages, it could give you anything you want because it has the requisite features to do that. The only thing that is actually missing is it's not dual core, but actually that's kind of okay because I think that's a battery hit that you can't really take with a wearable. But yeah, also it uses Arduino and MicroPython, so you can pick your flavor of programming language you want to use for it. Right, the challenges of timekeeping. So this is, you think that, like, I think at the, we are almost at the, like a golden era of like physics understanding. You'd think that there would be a way that we could get past the idea of using an oscillator for timekeeping, like something that's actually physically vibrating so that we can count the number of vibrations and then keep time. But turns out there's actually no way to sidestep that. The best thing to actually is to have, so the first oscillators were they were the pendulum clocks. This was in the 1700s, I mean earlier. And anyone who was into mechanics at that time, Galileo, Kepler, Newton, anyone worth their salt and who was into mechanics made their own kind of escapement, which is basically how you have a wheel that moves the pendulum given its time period, given the length of the pendulum. And they created more and more complex escapements. And the incentive there was to get a clock that would work on a ship. Because without a stable ground reference and something that's constantly shaking, you wanted a clock that was stable, right? So we moved away from pendulum clocks, we went into spring-powered escapements, all of these things. A kind of tangent in the 1960s, late 60s, was this thing called the Bolivia Accutron. It's a transistorized watch. It's the first transistorized watch. This was before they invented quartz crystals, and basically, it was kind of a watershed moment in timekeeping when they invented the quartz crystal. But this was kind of the last bespoke mechanical attempt at making a watch. So it's half transistor. It uses an electromagnet to actually move this like weird pendulum in the middle, and it uses a transistor as a feedback loop so that it keeps it in line. Basically, again, it uses an oscillator, but it uses an electronic component to keep the oscillator from drifting. And then we invented this guy, which was the quartz crystal, which is in all clocks that are reasonably accurate, except Rolexes, which that's why you have to go and like, if anyone has owned a Rolex or know of Rolexes, you need to actually go and get them adjusted every few years because they drift. They're actually mechanical. Most mechanical clocks drift. So it's actually much better to use a quartz crystal. And this basically vibrates at 32,768 hertz. which is a power of 2. So you divide that by 15, 2 to the 15, and you get your 1 second pulse, which powers basically all clocks for the past, I don't know, 30, 40 years, even the cheapest ones. So that, it's an interesting thing about timekeeping, that you always need a vibrating membrane to keep time. Right? So a bit about how the actual product was made. The cases were, like, as you can see, were 3D printed on this commercial 3D, like the cheapest 3D printer that I could get. This is also an interesting thing to see the field move, the 3D printing field move, because over the last few years, I started out like 4 or 5 years ago, where the only game in town at the budget end was the Ender 3. And the Ender 3 is a notoriously finicky machine for anyone who's owned one. It basically prints 2 out of 3 times, and the rest of the time it fails. So it's not really good for printing large scale things like this, and like a large batch of things. But this is the Anycubic Cobra. So the same 15,000 rupees or something gets you a very, very good printer, highly repeatable. Not the best quality, of course. Now the game is quality and speed. That is what the 3D printing game is all about. If you pay more, you get more quality, you get higher speeds, the Bamboo Labs X1 or something like that. What the case was designed in, it was designed in Tinkercad, which is, I would say, is like the is the gateway drug that Autodesk uses to hook people young, I would imagine, because once you get used to that, you have to use their applications later. So they have an incentive to use it, but it's an extremely free, powerful free web tool that you could use. And it's intended to be used by children. So it's like completely, you could just pick it up, learn it. It has its limitations. There are Shaper 3D, there are various other 3D modeling softwares which are more geared towards 3D printing, which slightly different from modeling for like graphic rendering or video games or something like that, because those actually deal with only the external facade of the object. They're the mesh, the outside bit, while a 3D printing design software really needs to worry about how these planes intersect. So I found that you design something in Blender, you import it into a 3D slicer, and it turns out actually it's not really possible to print, because these it assumes that like these walls are 0 thickness or some really stupid things like that, which that's why you'd want a software that is geared towards 3D printing, even though there are much more powerful design software. This was the workshop. This was at the DevFolio offices in Indranagar. They were gracious enough to give us their space for one day to do this as an experiment. So we got people to sign up, and we ran them through a primer of basic electronics, and they were just asked to build this from scratch. It was quite a harrowing thing. It took much longer than expected because you have to account for the various skill differences, and also it's not that all of these people are engineers. Some of them were game developers, some of them were lawyers. They didn't all come from a technical background, but I think they really enjoyed building it from scratch, and it was a very interesting experience to have this kind of thing. I have never, the reason why I wanted an event like a build along or like a hardware hackathon like this is because I've never experienced this in India. Like, there are a lot of talking about it. I've been to a bunch of maker spaces, not maker, like maker fairs, and there's a lot of B2B interaction and all of this, but very little B2C interactions about like actual physical making. So yeah, just one. Yeah, that was this is the final thing after 6 hours. We thought it would take like 3 hours. It actually took 6 hours to get everyone to make the thing, and a lot of learning along the way of like how to optimize the kit so that it can be made by other people. So yeah, that's the end of my talk. You can find me at AmpereWorks on Instagram. Ampere.works is the website. We will be selling kits at the Absurd booth, and I'm open to questions. Yes.
Does anyone have?
So the screen, you can get it off, right, you could get it off this site called, there's this local reseller called RoboCraze, they're in Kamanali actually. But WaveShare is the manufacturer of the actual display. Yeah, so they use there is a Chinese company called GPD who makes, not the GPD that makes those little handheld computers, the different GPD, they make e-paper displays. And WaveShare is basically used theirs with a custom driver board. Yeah, you can get it off, here you can get it off like Robu or any of these electronic websites has this. It's a 200 into 200 pixel display. Yeah. RoboCraze, ROBOCRAZE.